Okay, welcome. Today's lesson is 73 sequences. What's our objective, class? Get ready?
73 sequences.
Sequences are fun. They're patterns of numbers. We've worked a little bit with them before. Today we're going to find the nth value of a sequence, but we're also going to identify what the patterns are in these really cool sequences. So recall, a sequence is an ordered list of number that follows a certain rule. They occur in science, nature, botany, statistics, sociology, population growth, accounting, finance. If you can understand a pattern of numbers, if you can understand what the numbers are doing, and you can write a formula or an equation for that sequence, you can predict what's going to happen down the road. You know, in 2 years, what will be the population? In 2 hours, what will be the bacteria growth? Okay, so that's with patterns of numbers. So let's look at this simple pattern of numbers. In sequences, we don't use X and Y, we use term number for the input, and the output is the value of that term. So our input, or N, is the first term, the value is 3. The second term, the value is 6. The third term is 9, etc. So if, without the equation writing right here, what rule can you say in words? What is happening to find these numbers? Hiram?
The number of term is multiplied by 3.
Oh, I like that. The term number multiplied by 3. Term number multiplied by 3. In words, the term number multiplied by 3. And then you can take that English and write it into equation. The value of the nth term equals 3 times the term number. So if I wanted to find the fourth term, I would take 3 and times it by the fourth term. 3 times 4, which is 12. If I wanted to find the fifth term, or a sub 5 is what we would say, a sub 5. What would we say? Get ready?
A sub 5.
A sub 5. It just helps us keep track of which term we're working with. It would be 3 times 5. So it would be 15. Then I can figure out the 10th term or the 20th term by doing 3 times the term number. So let's look at some other sequences. Look at this sequence. 2, 4, 8, 16, 32. Before we look at an equation, let's identify what's our pattern in words. How could I describe what's happening and what would my next term be? If you see a pattern, raise your hand. I just want to see if your brains are catching a pattern. 10, 11, 12, 13, 14. Oh, sweet, most of you. Okay, Tate, what's the pattern?
Use multiply by 2.
Multiply what by 2?
The number.
Okay, this number?
What do you mean?
So to be specific, so to find our next term, or our next value, we would multiply this one by 2, right? The previous term by 2. Multiply the previous term by 2. And then we would write that, we'd go times 2, times 2, times 2. And it has to work for every term. So our next term would be what, think? Get ready?
64.
Excellent. There's another way to figure out this sequence. It is a timesing by 2. But I want you to think about it like this. This is the first term, second term, third term, fourth term, fifth term, sixth term. Can you see a relationship between the term number and its value? Term number 4 is a 16. Term number 5 is a 32. And I'll give you a hint. It has something to do with 2. Okay, Spencer, what do you see?
Well, it's n equals 2 to the n power.
You're the only one today that's figured that out. Let's check. Is he right? He knew there's a timesing by 2. So he says the first term would be 2 to the 1. That would be 2. 2 squared would be 4. 2 cubed would be 8. 2 to the 4th would be 16. Great job, Spencer. So be looking for those patterns. Sometimes they're not obvious. Jacob.
So I was just going to say you have to play 2048 to figure those out. You have to play 2048.
Is that a game?
Yeah, that's how I know my two exponents.
Your squares? Okay, good. Okay, this one's got a special name because it comes up in science and botany, biology. And scientists said, whoa, look at this plant diagram. They said on our first row, we had one branch. Then on the next one, we had one branch. And then it went to 2, and then 3, and then 5. But if we were to add up the total number of leaves, it went 1, 2, 3, 5, 8, 13. I'm going to pose to you that the next number is 21. How did I know that?
Oh, look, that's very good.
If you see it, raise your hand. 2 of you, 3. The next number is 34.
I remember.
If you see it, raise your hand. You have to think, every sequence can be different. It can be like something with the previous term, something with a negative number, something with adding, something with timesing. What's going on? AJ, what do you see?
So you add the first one number and the second number to get the other number, and then that's kind of how you do it. It's like,
Ah, wait, so you're saying 5 plus 8 would give me the next number.
yeah, and then 8 plus 13 would be 21.
Ah, okay, so we're adding the previous term to the current term to get the next term. So what would my next value be? We would add these two, 21 plus 34, which is, get ready?
55.
55. That one's a cool sequence. It's called the Fibonacci sequence. What is it called? Get ready?
Fibonacci sequence.
Fibonacci. It's got 2 C's. I think it's Italian. Okay, how about this cool one? It's got some negatives in there. So let's think creatively. Be a problem solver. Look at clues. I see a 1, -2, 2, -1, 3, 0, 4. Dot, dot, dot. What's my pattern? Dakota saw it fast. Oh, okay. Okay, don't blurt it out yet. Let's give some thinking time for.
Not
I found it out.
Hands only.
Never mind.
Alex, give it John.
So, you would subtract 3, so 1 minus 3 equals -2. And then 2 minus 3 equals -1. And then it's the easiest to add 3 to 0 because
Okay.
it's minus 3.
So we got these -3s for sure. So let's see if it would be these two. Is it going to be these two right here? So this would be a 1. Okay, but how am I going to find where'd this number come from? So I have to find a way to do this number here. Let's see who I'm going to call on. Hiram. Plus 4. You guys got this faster than the other classes. Plus 4. Okay, so my next one is supposed to be a plus 4, and the value we said was 1. So the next one would be what? Get ready? 5. Okay, my brain actually, the first thing, I didn't see this. I saw 1, 2, 3, 4, 5. That's how I found the 5 pretty fast. And then I was like, wait a minute, I see -2, -1, 0. It's counting up by 1 on the other numbers. So -2, -1, 0, 1. This would be a 2. I'm counting up here, counting up there, counting up, counting up. So I saw that. So you can see it different ways and get the same sequence. Okay, we talked about that one. So this is another cool thing that it happens in conic shells is the ratio of area. So it's the Fibonacci sequence. 1, 2, 3, 5, 8, 13. The areas add cumulatively to get the area of the inside of the shell. It's kind of cool. Okay, what if they didn't give us the list of numbers, but they gave us an equation? A sub n equals 1 plus 2n. Find the first 3 terms. So that means find a sub 1. Well, to find a sub 1, you substitute 1 in for n. How do I find a sub n? Get ready?
1 in for n.
1 in for n. To find a sub 2, I put 2 in for n. To find a sub 3, I put 3 in for n. So I'm going to just multiply first, then add. 2 plus 1 is 3. 4 plus 1 is 5. 6 plus 1 is 7. So I can see my pattern. 3, 5, 7. The next one would be 9, 11, 13. Okay? This one's cool. This sequence starts with 1, 3, it's growing bigger, 6, growing even bigger. How is it growing? If you see the pattern, raise your hand. What's my pattern? How is it growing? How is it getting bigger? How is it increasing? What you're thinking is, what is it adding? Or what is it multiplying? Okay, Chelsea?
Well, first one you had 2, the next one you had 3, the next one you had 4, the next one you had 5.
How'd you smart? Hey, you know, on your practice set, you're gonna have to do this since I had students be some. Well, I know this, like I know this, I just don't know the next term. Yeah, you do. You do. Because you'd add 6. It's 21. Next term we add 7. What's the next term? Think. Get ready?
28.
And the next term I would add 8, which would be?
30.
Get ready?
36.
36. Okay, good. Oh, by the way, what is the significance of this triangular sequence? 1 dot, 3 dots, 6. Okay, 1, 2, 3, 4, 5, 6. 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 15 dots. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 1, 2, 1. I messed up my counting, but that's going to be your 15. So that's where this sequence comes from, is taking and adding another row onto the bottom of your triangle that has 1 additional dot. Cool. You can find this sequence with this formula. So if I wanted to say, hey, by the time I did 10 triangles, how many dots would it have? I don't want to draw 10. Guess what? I had 2 students draw 10 triangles. You don't need to draw 10. Just put 10 in for n. 10 times 10 plus 1 is 11, divided by 2. To save work, I'd cross cancel there. 5 times 11 is 55. So there would be 55 dots in my 10th triangular number. Hey, and that's it. 493. Take a stand up for 20 seconds.